Okay, so thanks. And my name is Antonio Zurlo. I'm a cloud engineer, specialist on HPC and ML on Google Cloud. I'll be talking about basically what the GCP Google Cloud Platform is, give you some information about the services and all the tools that you can use on Google Cloud, and in the end mention what we've done so far with KX, KDB, and some ideas of how deploying KDB on Google Cloud can look like and what are the pros of doing something like that. So Google Cloud is a pretty large investment, I would say, from Google. I don't even know if this slide is updated, probably not. But I mean, we have a pretty big commitment on the service, and we have quite a big footprint as of today on in this space. You probably have used most of these services, so you're using them currently. I'm just going to focus on the last one, the last icon right here, which is our public cloud offer. Keep in mind that when you deploy something, application, use some service out of a Google Cloud Platform, you're pretty much using and running on the same platform where Google Search or Google Maps or Android run. So you have the same level of performance, security, scalability that all these other services are using today. And we've seen like millions of users, billions of users actually use these services on a daily basis. So this is like a map, and I'm not sure that this is like up to date, but I mean, you can see that pretty much we have a presence in almost every part of the globe. So we have zones. So zones are areas where we have data centers. Actually, we have regions that are the one in blue, and within the region you see a number, that corresponds to the zone. A zone corresponds to a physical data center, physical Google facility, and zones are like geographical regions where these facilities are concentrated. We have new ones announced, and I'm sure again, and this map is evolving pretty rapidly, pretty quickly. So I would say we are definitely compatible or comparable to other public cloud offers existing today. So in terms of what you get when you use Google Cloud, you get like you get some building blocks at the bottom. You can see these are icons, part of the icons of like representing our services. So you get compute, you get network, you get storage. On top of this, you get a bunch of pre-built, existing, built-in services. So things for doing, for example, machine learning, for doing NoSQL, for doing data preparation. So something that was mentioned before about parsing the entire Harry Potter book. It's something you can do through an API. So you can send your content to an API, which is a Google service, in this case, NLP API, and just have that service done for you on demand in the cloud. Same thing if you need to translate a book from one language to another, and so on. Plus, a bunch of other services for image recognition, and we'll see more of the other features around. Other things are what you expect, like PubSub, for example, data flow for ETF, and data prep and data studio for visualization. So you can have a mix of pre-built services like these on which you deploy your own infrastructure as a service. So you can create VMs, you can create like Docker containers, leverage Kubernetes, and still from the same environment, like consume these pre-built services that are part of the infrastructure. So TensorFlow, which I think has been mentioned before, is an example of one of our internally developed technologies that then has been released as open source. We also have, we are the only place where you can use so-called TPUs, TensorFlow Processing Units, which is a specialized piece of hardware to speed up and to make like your TensorFlow calculation much faster, much more effective. So the only way, at least for the moment, to use TPUs is to use them in Google Cloud. And you can use TPUs just like together with the other things like GPUs on a per second base unit like service, as well as in a virtualized mode. And I'll explain to you what that means. So I have a few slides now around like the building blocks. So we've recently completed a very, I would say, very successful benchmark with KX, with KDB, using some of these, actually a bunch of these building blocks to squeeze out like some very interesting performance out of the platform. So again, we have, I would say this is like a screenshot of our portal, so you can choose from a much longer list than this. I cannot scroll, make it bigger than this, list of operating systems. You can customize the size of your VM, so you can create things that are some odd, like for example, you can create, I don't know, a 13-core VM, or something that with the amount of memory that you decide. So, and this is something that you do out of, again, using the portal and creating your custom size of VM and then mapping to assigning an operating system. You can use GPUs and TPUs in exactly the same way. So you can attach, for example, a GPU to a VM. And then you can, out of there, you can access all the other services that are pre-built in the environment. So you get sustained. One thing that is built in the infrastructure is an intelligent way to measure your behavior. So you can get recommendations. I don't know if you can see it here. It says you could be better off, like you could save some money by resizing this VM. So you started with, I don't know, with 64 cores and some amount of memory. The system will observe your pattern of utilization. It will make you recommendations about saying, from the way you're using the VM, you could save some money by scaling down to, I don't know, 24 or 16 cores. And once you make the decision, it's almost like a vMotion type of experience. So you don't have to shut down or destroy the VM. You can just like resize it without any interruption of service. And you can see here that you can customize the size of your box. We have preemptible VM instances. So these are VMs that you borrow from the infrastructure at a much reduced cost, and that can be used for research, for example, for a type of non-time critical activities. We have per second billing, so if you use the system for 65 seconds, you get billed for 65 seconds and not for 2 hours, for 2 minutes, or for more than that. And we also give you like a discount based on the volume of your consumption. You can create instance groups, so you can group together a set of VMs and assign the same behavior, configure the same behavior for them. So imagine deploying a cluster or something that requires more than one VM. You can configure the entire group of machines as a single unit that you manage as a single item. Intel Skylake is the top line of our processor available on GCP. Again, you can, in this case, you can create like up to a 96 core instance of with 2 gigahertz like frequency and so on. And this instance comes with the Intel Parallel Studio already pre-installed on the VM. You can leverage GPUs. Again, GPUs, important things to note is that, again, these are also per second billing and preemptible. So you can even borrow a GPU on top of a VM. Let's talk about networking. So as I mentioned before, the Google network is one of our strong points, I would say. It's a super scalable network. Imagine that one that serves Google Search, Google Map, YouTube, and so on. We have thousands of point of presence. I have a map, I think, in the next slide. So a point of presence, which is one of these dark points, is a Google facility. It's not a data center. So there are no VMs or networking like routers and hardware in there. It's just a way to get into the Google Cloud, into the Google network. So once you reach a POP, so even if your region is not covered, like in this case, once you reach one of these points, you're already on the Google network. So you have all the, the encryption, scalability, performance, low latency that you experience if you're in one of the other regions. The yellow points are the edge node location. So imagine Equinix. So you can run your connectivity to Equinix, and from there reach either a POP or reach a physical data center. The green lines are our oceanic cable. So Google is the single owner of the largest private network on the globe, and we deploy our own transoceanic cables that you can see from here to here, and we are actually doing more even these days. Let's talk about storage. So Google Cloud, there are several options. Google Cloud Storage, which is our object store. Persistent disks, these are SSDs or HDDs that are preserved after you shut down or destroy a VM. So if you need to store some data, you have this option, of course. If you need something more performant, you can store into a persistent disk. You can use local storage, so local SSD. We support NVMe, and these are, again, ephemeral disks. So when you destroy the VM, this data goes away. If you want something to be persistent, either use this solution or this one. And then there are on-site solutions. So again, we have partnership with the companies like Elastify. We allow you to ship your an appliance with a teradata of data that you want to store in the cloud. One thing I didn't mention here, we have solutions for long-term storage, so then cold store and nearline and cold line for long-term storage solutions that are extremely cost-effective. Just a little bit more details about local SSDs and persistent disks. You can see some data, some information here with the cost attached. So remember, these are the ones that are ephemeral. These are the ones that are persistent and can be, basically, you can persist between several instances of across the life cycle of your project. I mentioned the object store. So object store is what you can imagine. Again, it's an object store in the cloud. So we have, again, multi-regional, regional, according to how you plan to replicate your data. We have something called nearline and cold line. So cold line is the long-running, retention data store. Nearline is something that is immediately available but is still subject to long retention. And these are the more, again, readily available solutions. We have something called GCS Fuse, which is a POSIX-compatible file system built on top of GCS. Mentioned here. So this is where I wanted to get. So this is like an idea of a potential use case. So again, the advantage of running something like KDB Plus in a GCP, so besides all the performance, the network, the security, the disks, and everything else, which is true, by the way, you can also, the advantage of dropping and installing KDB in GCP is also the fact that now you can, this box is the GCP cloud, you can integrate KDB with all these existing systems. So for example, let's say that you need to do some complex data ingestion. So you need to do some ETL activity before you load data into KDB. You can leverage things like data flow. You can stream data through our PubSub API. By the way, you can also go directly from here to here. You can create a pipeline. We have something called Composer, which is an managed implementation of Apache Airflow. It allows you to create a workflow of activities. So you can monitor, you can attach behavior in terms of rerunning a task that failed or notifying somebody once you make you create a complex workflow like this. So for example, the ingestion of the Harry Potter book can be done by processing and translating or tagging the text in this phase before you load the data into KDB. On the other hand, which is even more interesting, you can, using Embed Pi, you can interact with our machine learning set of tools. So for example, you can train a model using TensorFlow and using TPUs. And then once you're happy with your model, you can deploy the model in Cloud ML and just use the prediction by calling, basically like running your predictions by calling from embed Pi that service to a REST API. So in this case, pretty much everything that you see in this picture is completely deployed and managed for you by GCP. You're sitting at this level, so this is your user experience. You just need to trigger a process, upload a bunch of data, and then maybe on the other side, like visualize your results using Tableau or Excel or any other tool. So everything becomes, again, a control. I mean, there's a bunch of other icons that I could put added to this picture, like monitoring and alerting. So you can collect like statistics, monitor the activity, again, branch off from one of the steps to other services, and so on. But this gives you like an idea of what is the real big advantage, I think, of using, like combining the two technologies. So not only you has all the benefits of running the full scale power of a KDB KDB on a cluster environment, but also you can, without having to create and manage these other services, use these other services for as complementary to your workflow. Okay, thanks.